when we were looking at balance equations, I said it's okay for you to hang on to your emotional attachment to whole numbers for now. And there will be a time that you will need to set that emotional attachment aside and you will have to deal with fractions. This is it. When we start talking about standard enthalpies of formation, you will be dealing with equations where you must use those fractions. And the reason you must use those fractions is that standard enthalpies of formation talk about the amount of heat evolved when we make 1 mole of product and 1 mole only. And we make that product from elements in its natural states. So, in order to accommodate diatomic elements, if we only need 1 mole of the element, we'll have to use half of a mole of diatomic, or 3 halves if we need 3. So this is the time where you get forced into that situation. Now, when we talk about standard enthalpies of formation, delta H 0 sub F, 2 important pieces of information. This little superscript 0 means 25 degrees Celsius, 298.15 Kelvin, and 1 atmosphere pressure. And the F means that we are making 1 mole of substance from the elements in their natural states. So we can look these values up in your textbook in Appendix 2. It's on page A6. And there's also information on free energy and entropy, but you can just ignore that for now. So we're going to practice writing thermochemical equations for the formation of a compound. Then we're going to practice using them to figure enthalpies of reactions. So when we write a thermochemical equation for the formation of a compound, all reactants are elements in their natural states. We make 1 mole and 1 mole only of product. We have a balanced equation. We include subscripts for physical state. And the delta H 0 sub F is part of the equation. So here's an example. This is the formation, not the information. For the formation of silver bromide, this is what it looks like. 1 mole of silver plus 1/2 mole of bromine liquid yields silver bromide solid, 1 mole. Delta H 0 sub F is negative 100.4 kilojoules per mole. Now, you have to know what physical state things are in their natural state. So the periodic chart is your friend. If you look up here, you'll see colors, black, blue, red, and then shaded out. What does black mean on the chart?
Solid.
Means it's a solid in its natural state. Red, gas, blue, liquid, and this block, not undetermined. It means that it exists in a nuclear reactor only. These are not naturally occurring elements. So it's not surprised that a lot of the transuranium elements fit in that category. But what always surprised me was technetium, number 43. It seems kind of crazy that we have all these elements, and we're getting up to, in the 90s here, but we skipped 43. I just think some days about the big guy upstairs making the earth and hanging out saying, well, today I'm going to make the elements. And here's number 41, 42, and his wife says, hey, honey, dinner's ready. Goes and eats dinner, comes back, 44, where'd I leave off, right? And just kind of skipped technetium. I think that's kind of crazy that doesn't exist there. So that can be helpful to you. And that will be on the wall. Now, when you take the final exam, you get a non-color-coded periodic chart. And I think they tell us to turn that one around so you can't see it. But by this time, I think you know what most of those noble gases are, that they're all gases. And you know nitrogen, oxygen, fluorine, chlorine, and hydrogen are gases. And by this time, I hope you know the 7 diatomic elements. I bring clay for our new house, right? So it should be pretty easy for you to put things in their natural states at this point in time. So now we're ready to write these equations for the thermochemical formation of calcium carbonate solid. The way I think it works best is to start off by looking at this and say, okay, I need 1 mole of calcium carbonate. So I start with the calcium carbonate solid on the right-hand side. And then when I look at that 1 mole, now I add the standard enthalpy of formation, delta H0 sub F is equal to negative 1206.9 kilojoules per mole. I know most of you don't bring your books to class, so I put these numbers in here. On the test, you might have to go look these numbers up in a chart that would be attached to the back of your test. Now we think about, how do I make calcium carbonate? What do I need to make calcium carbonate? I need some calcium, right? I need 1 mole of calcium. Calcium is a monoatomic element, and it is a solid in its natural state. It's black on the chart. What else do I need? Carbon. It's also a solid on the chart. What else do I need? Oxygen. Now, oxygen comes in pairs, O2 gas, and I need 3 oxygens. It is not okay to do the multiplying by 2 thing here, because I have to make only 1 mole of calcium carbonate. So now I am forced to use 3/2 of oxygen gas in order to make this material. So this is where you must use those fractions. Okay, let's look at one more. Ammonium chloride solid. Ammonium chloride solid, 1 mole. We write the proper formula. We add in our enthalpy of formation. It's equal to negative 314.4 kilojoules per mole. What do I need to make ammonium chloride? Some nitrogen. Like that. N2 gas. So how much do I need? 1/2. What else do I need? Hydrogen. 2 moles of diatomic hydrogen. And what else do I need? 1/2 mole of diatomic chlorine gas. And now I've made ammonium chloride. It's what? That's it. Because I now have a balanced equation making 1 mole of product. I've included my subscripts and I've included delta H0 sub F. So that's it. Just take a minute at your seats now and do these next problems, the next 2.